out the shortest segment from a point to a line theorem, and we need to remember that it's an if and only if statement. So that means that we need to go in two directions. We need to go in this direction, and then we need to go in the other direction, which I'll put up here. And let's write out the proof for the one direction. So this is saying, that it's if and only if. So the one direction is if PM is the shortest segment from P to L, then PM is perpendicular to L. Now, you always, in both of these, in both directions, right? The other direction is what? Let's make sure we're able to do that. If, right? What? PM is perpendicular to L, then PM is the shortest segment. Is shortest segment from P to L. And in both of these, okay, in both of these proofs, I'll do the other direction in just a second, but in both of them, you want to assume the opposite of the hypothesis. So you want to assume the hypothesis false. So I want to say assume. In this case, you want to assume the opposite of the conclusion. Was I saying hypothesis? I apologize. You want to assume the opposite of the conclusion. This is the conclusion, right? Here's your conclusion. The hypothesis you need to be true. So you assume the opposite of the conclusion in both of these. I apologize. The conclusion is here. So you want to assume segment PM is not. That's the opposite of the conclusion, is not perpendicular to L. Now, if you assume this, you got to look at now what's happening. So here's some line L, and then here's some point P. And in this case, I have some line PM, and I know that PM is the shortest. That's what's the hypothesis. So this segment from P to M is the shortest line from P to L for any point on L. But if I assume that it's not perpendicular, that must mean, okay, because there's always a line that is perpendicular. So let's say it's that line. And let's call this point K. There must exist some PK that is perpendicular. That segment must always exist as a postulate. That from point P to L, there exists a line perpendicular to L. There exists a line through P perpendicular to L, and PK is that segment. So then, since we know and there's only exactly one, and that's key, there's only exactly one. So PM is not that one. So there's only one segment from P to L that's perpendicular to L. And I'm assuming that it's not PM. So then it must be some other line, PK, that is perpendicular. So then there exists PK, some segment PK, perpendicular to L. Now, I sit here and I remember what it is that I have. I have that PM is the shortest segment from P to L. That means by what's given, it's given to me that PM is the shortest. That's what I'm working with. I'm given the fact that PM is the shortest segment from P to L. I want to prove that PM is perpendicular to L. So I'm given this. So by given PM, the distance between P and M has to be less than the distance from P to K. Okay, because these are both segments from P to L. PK is a segment from P to L, and PM is a segment from P to L. And I know by my given that PK is the shortest one. So that's why this is true. However, if we look, triangle MK is a right triangle with what as its hypotenuse? With, well, if this is the right angle right here, the hypotenuse is opposite the right angle. So PM would be the hypotenuse in this case, with PM as hypotenuse. This gives, because what's the longest side in a right triangle? The hypotenuse. So PM is the hypotenuse, it must be the longest side. This gives PM is greater than PK, because these are both sides in the right triangle, right? PK is the side, PM is the hypotenuse, and the hypotenuse must be the longest side. So PM is greater than PK. And then you could say, which is a contradiction. And you could write this symbol to symbolize the idea of contradiction. Thus, or therefore, same word, thus, our assumption is false. And then just write the opposite of our assumption. Our assumption was that PM is not perpendicular, right? PM is perpendicular to L. And then we're done with this proof. And you could write, for paragraph proofs, you could put a little bit of flair. You could draw this symbol. It literally means it has been shown, okay? QED, whatever, there's other symbols you could put. That's just to symbolize the end of your proof. But that's only in one direction. Now you need to do it in the other direction. Excuse me. Okay, now the next direction. Okay, again, start off with assuming the opposite of the conclusion. So the opposite of the conclusion in this case is that PM is the shortest segment from P to L. So assume PM is not the shortest segment from P to L. And then right away you should again look at your little sketch, take a little sketch, and I would definitely recommend doing a little sketch L. And in this case you know that PM is perpendicular to L. That's all you know. Okay, that is perpendicular, that it forms right angles. But you're assuming now that PM is not the shortest length. So that means that there's some other length, PK, that's shorter. So then you have, then there exists segment PK shorter than PM. And the way you say that is that the distance from P to K is less than the distance from P to M, right? This segment from P to K, right? That must be shorter than PM. PM is not the shortest length, but there must exist some length. Then, if it isn't the shortest, then there must exist one that's shorter. Whatever, let's find. Then it must exist. Let's call it, PK must be shorter, right? So then I get this statement. But we know that triangle PMK is a right triangle with segment PK as hypotenuse, which gives because we know the hypotenuse is the longest side, which gives that PK must be greater than PM. This is in contradiction with this one. PK is less than PM and PK is greater than PM. That's not possible. This is a contradiction. Thus, our assumption is false. And again, right, just what the opposite of your assumption is. The assumption is that PM is not the shortest, right? PM. Just to conclude with what we wanted to prove. We wanted to prove that PM is the shortest. So we say our assumption is false. PM is the shortest segment from P to line L. And again, you could put some little flair here to prove your statement, and you're done.